Good morning. Let's start my talk. Data modeling for software engineers. Make your data leaders smile again. Make your architects smile again, your product or your business analysts, perhaps your whole organization to smile again. Now, I'm assuming most of us in here are software engineers of one sort or another. How many of you actually believe you are modeling data? Raise your hand. More than I thought. But I think by the end of this, we'll convince most of you that maybe all of you are modeling data. So what are the benefits of data modeling? This is kind of weird because my eyes are not that good, and when I'm closer to the screen, I can read my presenter notes. Um, Data modeling makes it easier for developers, data architects, business analysts, and others to view and understand relationships between data. Reduces errors, increases software development, improves application and database performance, ease data mapping throughout the organization. I think that's what we do. I think that actually a lot of this we do in software engineering as well. Now I'm going to go back in the day, many, many years ago, where data architects were a key part of the software engineering process. The data architects would often speak to C-levels, VPs, the important people in the organizations. They would talk about what is important for the organization in the mid to long term. Where are we going? What are we doing? New initiatives? Where are we doing well? Where aren't we doing well? They would tell a story. The data architect would also fill back information to the C-level about some of the things we're doing with data, successful or not, where we're able to leverage the data that we have, where we're not able to leverage the data we have. She's going to talk to the product people or the business analysts, short to midterm things that are happening, the initiatives that are currently being worked on, the projects that need to get done, the deliverables. Again, the data architect wants to know what's happening, what's the timelines, what's important, what are some of the dependencies, and again, two-way conversation. Now, the data architects need to talk to legal because you want to make sure that what you're doing with the data within the organization is legally justified. It follows the contracts that your organization has signed. It has privacy or compliance handled correctly, things of that nature. Now, in many organizations, the data architect maybe does some basic data modeling, but doesn't do the logical models or the physical models. Often you have a team of a few data modelers who work with the individual initiatives, work with the individual teams to get the model ready for development. Because once upon a time, you completed your data model before you actually did any engineering. Now she's probably talking to the DBAs. Again, different organizations do different things. The DBAs may be responsible for taking a logical model and turning it into a physical model. Or they may take the physical model developed by the modelers and work with the data architect to understand some of the use cases, access paths, where are some of the issues, go back and forth, make sure that when we implement the model physically, it actually is what we want and it's going to work. Now, the software engineers on the initiative probably get an introduction to the data model and get to be explained what we're doing, why we're doing it, what are some of the decisions, why is some of the data that maybe they expected to be there is not structured or is not there as they expected. Again, giving an understanding to the engineering team about the data, what they're doing with it, things like that. And finally, the data architect is responsible for governance, the data governance. At its bare bones, it's things like naming, vernacular, data types, standards. It can go into things like the life cycle of a set of data, when we must archive it, things like that. Ultimately, a living document, but it's the data story for the organization. And overall, the data architect is actually telling a cohesive story about data through the organization. Oftentimes, the data architect knows the business better than the business knows itself because she's talking to all sorts of players to understand those things. Not so much anymore. That was then, this is now, where we've empowered teams to own a solution from inception to deprecation. This isn't saying that every organization has gotten rid of data architecture, but there's definitely been a reduction in its emphasis. Again, It used to be a precursor to all engineering efforts. Now it's an afterthought where the data architect is often looking at the data after it's been captured, after it's been created, and trying to make sense of it. This is, yeah, this is a well-known cartoon. Three blind people, or in this case, blindfolded people, are feeling out an elephant, and they're coming up with different conclusions about what that elephant is. It's a rope, it's a wall, it's a snake. And the reason they're coming up to it is because their context is very small. And a lot of what I see is engineering teams have just a small context, and they work within that context. They don't understand the overall picture. There is no data architecture to give a color or flavor or whatever terminology you want to use for the data. It doesn't exist. Teams are working in silos. Maybe they know something adjacent to them, but the overall picture is lost. So what could go wrong? Lots of things. The understanding is not there. Because there is no one telling a complete story, the complete story probably doesn't exist in anybody's head. People might be able to assemble a few things, but they don't know the complete story. They're more focused on what they're working on. And therefore, the completeness isn't there. Within an initiative, there might be things that you're doing that you think are important, data that you capture, data that you handle, but in fact, there's a wider range of things that perhaps you should be doing. But because you don't have that complete understanding, the completeness of the data you're dealing with is questionable. Therefore, the quality is questionable. Again, if you haven't captured the right data, you don't have it. Or if you capture the data, but maybe not in the form that might be usable to others. You've captured it how you want to look at it. You don't necessarily have what everyone else needs to look at. And therefore, the usability is questionable. The usability being, after I do something with the data in my initiative, in my solution, then what? And again, if you don't have that complete understanding, the usability of that data farther down, AI, ML, reporting, whatever, might not be there. Of course, if you're that engineer, you're like, I don't have time for the end-to-end story. I've got a story, I've got to write it, I've got to develop it. The sprint is done at the end of the week. Get out of my way, let me start coding. Of course, that may backfire on you when you're asked to redo it again and again as a bigger picture becomes available. Now, this is a very famous advertising campaign, A Diamond is Forever, created in the 50s, I believe. What if I was to tell you data is forever? But in fact, the software that you're writing today is probably not. The data that an organization has captured through an application years ago might still be around today, but that application might have been rewritten. Or you might have microservices today where you didn't before. The chances are that the code that you write today is less important than the data that you capture. Because the data that you capture, whether it's in its original form or a subsequent translated, interpreted form, is probably there for a long time. Of course, you have social media idiots who really wish that you didn't capture data forever, but it's there. So why should you believe me? Who am I? I've been doing technology for way, way too long. And I've been an architect in many different forms, including data. Now, I don't do data architecture hardcore today. I haven't done it in a long time. But I bring that data architecture experience to the table almost every day. My most recent position, I was a software engineer, day-to-day engineer doing day-to-day code writing. But often, I'm mentoring people as well on the decisions you're making from a data perspective. Obviously, I'm a speaker. That's why I'm here. I do writing. I do some mentoring. And I'm a traveler. I love to travel. Surprisingly, this is the second time I've been to Oslo in about 6 weeks. My wife and I were here on vacation, and then I got accepted to speak here. Now, the accent probably gives it away. I'm from the United States, but I've heard a lot of people don't know where Minnesota is. Minnesota, upper Midwest, gorgeous summers, miserable winters. If you say you don't know where Minnesota is, you're lying. Prince is from Minnesota. So, some of the goals we have today. Data modeling. Your design, your implementation decisions impact your solution's viability and potentially your organization's success. In software, we often talk about decoupling and having loosely coupled, highly cohesive solutions. I think the same thing applies from a data perspective as well. To me, it seems like we should decouple data and how the data is viewed from the outside world is different than what your actual implementation is. And then we'll do wrap up, other considerations, final thoughts, Q&A if we've got time, though might be difficult in this forum. Things that we're not doing. This is not a data model tutorial. As much as I would like to, there are too many different ways to model data and too many different ways that an organization expects to model data, even if you did something formally. Might depend on industry, technology, non-functional requirements, things like that. I also can't help you turn your organization into a data-first organization. We are at the bottom of the food chain. We're not going to be able to drive that. You need your senior leaders to come to that conclusion and push it from the top. I also can't help you with your career paths. If you want to get into data, we can talk afterwards, but there is no single solution about how to move from an engineer into a data world, whether you're doing reporting, data warehousing, AI, ML, anything like that. So this painting is in the Met Museum in New York City. The placard for it is on the right, the placard being the thing that's on the wall that describes the painting. And I look at that, and there's a lot of data in it. And I admit, my wife and I do lots of museums. The amount of time I spend looking at these placards from a data perspective is embarrassing. I read them. But I look at this, and there's a lot of data in here. At the top, you've got the artist's biographical information. Where he was born, when he died, Rapino, they actually renamed the town that he was living in to his last name so that he died in a town of his name. It was part of the St. Petersburg region, Kukala being part of Finland, probably Karelia that was part of Finland up until World War II. He lived from 1844 to 1930. The second part is the painting's biography. Vasilabad Mikhailovich Garshin, 1855 to 1888. The painting was done in 1884. It's oil on canvas. Now, the larger description kind of includes both the artist, the painting, and the subject's bibliography, a little more expanded. There's parts in there at the top, again, talking about what's in the artist's biography. The middle, he met Garshin, accomplished writer. Garshin ultimately committed suicide, blah, 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 blah. Describing the painting in with a little more words. Now, I don't know what the Humanities Fund is, but they had this picture and they gifted it to the Met in 1972, and that's the quote-unquote primary key. How does the Met identify this acquisition? How does the Met identify this piece of work? Now, I look at this and I see many different ways that you might model this, whether it's relational, whether it's NoSQL. I can even think of ways that you might do it with a graph database. It depends on what's important. It depends on what you're trying to achieve. If somebody at the Met wants to pull up all paintings, oil on canvas, not oil on wood, from Russian artists who were born in Ukraine, you probably got the data somewhere that you could do it, or you hope that you have the data to do it. So again, what you're trying to do with that data becomes very key to how you're modeling it. You want to make sure that it's usable down the road. I just gave an example for querying. There's plenty of other things as well. So, how is data used in your solution? The obvious one is persisted, right? You've got a database server where you store all the data. It's SQL Server, it's Oracle, it's Mongo, it's Couchbase. Whatever that is, there's a back-end server where you are doing some level of operations to store and or retrieve data or delete data. CRUD operations, create, read, update, delete. How about APIs? APIs are data. Think about it. The URI, the components of your URI, whatever you define, those parts are data. The query parameters, how you name the query parameters, are they a certain data type? Is it an array? That's data. What's in the header is data. You might actually, some API standards, put the version number of the API in the header. You might have a transaction ID in the header that spans a whole number of calls together. The request and the response itself is data. So when you define an API to the outside world, there's a lot of data components there. Eventing, messaging, something important has happened. Your solution wants to notify others through a published message of some sort or raising an event, depending on the technology. It may be that it may be as simple as I created a class, I created a student. It may be that a business object changed, that a state lifecycle change occurred. But again, what's in that message, what's in that event is data. How granular your messaging is, and the data that you put in that message is all data, how you model it. And we're not going to go in as deep detail, but hardware solutions. My watch, my smartwatch has GPS. If I go for a run, it keeps the number of steps and my direction and how long, and it stores it in a very optimized form on the watch, which is then uploaded to my smart device, my phone. Back in the day, prior to the supercomputers that we hold in our pockets on a daily basis, we would have like a Garmin device for maps to help us with driving. And again, you would get in a very small underpowered device enough data to drive large distances in the US. 10, 12 hours I know that a single map would have on it. So there's different types of things that are considered data. On a hardware device, you've got to be very careful about what you're dealing with because again, you don't have as much as you might have otherwise. How is data used? We kind of talked about this, application data. Many of us are writing business applications where certain things happen transactionally. They're often called transactional databases or transactional activity, CRUD operations. I'm writing educational software. I create a student. That student is retrieved so I can assign her or him to a class, things like that. Reporting. I aggregate the data to give me a view of the state of the business, to tell me whether I'm being successful or not, could help drive financials. Am I doing the right thing? Are there new business opportunities based on the data that we've gathered? I could be integrating with a third party, usually an external vendor who is providing something that is perhaps not my core competency. For example, I worked with a company, they did medical software. In the US, it's called post-acute care software, and one of our pieces was for a nursing home for senior citizens. We did not do meals. We did not do the meal planning. We integrated with a third party, whom we ultimately bought, that was responsible for creating the menus, watching for allergens, doing caloric intake, making sure that the senior citizens' main contact person, relatives, knew what the menus were, getting the food ordered for us. That was not our core competency. We put that out to somewhere else, but the APIs and the integrations that we did were all various forms of data that we were doing. Could be that your data is intellectual property. I actually ran into this today. Google has data, we know all sorts of data about us and is using it. Facebook is the same. But it might be that the data differentiates you from your competitors, that the data that you have can drive business opportunities that your competitors can't match. Again, worked at a company, we did mortgage banking, and one of the senior leaders, she was not concerned about our code getting out into the wild. She couldn't care less if somebody stole our code. She was more concerned about the data. She felt that the data was our key component, that that's where we were differentiating it. And it did. It helped us make better decisions using various engines that would allow us to price our mortgages correctly. In fact, it got to the point where we were able to provide these services to our competitors. Our competitors would run their data through the same service, would come out with a response, and it would say, they would often tell us, yeah, this isn't for us. How about you? You want to buy it? And in fact, they're paying us to use our service, and then they're doing the dirty work to give us the loans that we would buy. Now, whether Mark Twain said this or not, very famous American author, is questionable. I've seen that he did and he didn't. But I agree with this. From a data modeling, from a software engineering perspective, you better know what you're going to do with the data before you gather it. A data architect, a friend of mine, Julie, she got burned too many times where people said, just capture something. We think we're going to need it down the road. And in fact, it backfired on her, because then we would have data that was taking up space, that nobody really knew what the meaning was, and as a result, we would make bad decisions. So she started saying, we're not capturing the data until you can give me a use case. Up front, you better have a use case for that data, because again, you want to know what you're going to do with it, and too often people didn't. Now, when you use the term data modeling, It screams waterfall. It screams iterative. It screams formal methodologies. Because as I said earlier, you would have the data model complete and implemented, especially in a relational database, prior to writing code. That's not what you do today, obviously. But today, the code changes, whatever you implement, is data modeling, whether it's persisted or published or exchanged, cached, measured, whatever. So a few things I want you to know before we get into it. Never means maybe. I think this goes for software engineering in general. How many times have we been told, this will never happen, and 2 weeks later, they change their mind after you've completed your coding? Certainty is fleeting when business requirements change. Business requirements change all the time. I would say all your changes are impactful. No change is without consequence. No data change is without consequence because everybody can see what you're doing. In your IDE, VS Code, Visual Studio, IntelliJ, whatever you use, whatever languages you use, you can bring up your project, you can bring up the code base, you can, number one, hope for some level of code comments that tell you what's happening. You can navigate from function to function, class to class, module to module, and get an understanding of what that code is doing. You can reverse engineer it. There is no equivalent for data. There is no IDE for data per se. Yes, you might have something like an ER Studio or Irwin where a data architect or data model has done the modeling. But again, how complete is it? How correct is it? Unknown, and how many people are, have access to it? Mostly what you have for data is like in a relational database. You'll describe the table. What does that tell you? What's the name of the column? What's the data type? Is it optional or not? If you want to dig into the metadata farther, with some weird queries, you can pull up some other information about foreign key referential integrity, what have you. If you query from Mongo per se, what do you get? You get a series of documents. There's no code comments behind it. So again, a little bit more difficult to deal with. And formal documentation, I mentioned, data models and Irwin. These days, fewer are created, fewer are looked at, and none of them are right from the moment they were last created. So what's important? In a data model, what is important to me? Consistency is really important in my mind. Data naming, more important than code naming. If I call something in my code Sushi Blowfish Wednesday, nobody cares except the person who comes after me to look at the code. No external consumer cares that the code is structured this way or has weirdly named things. It doesn't matter. But from a data perspective, anyone and everyone can see what the naming that you've used. If you are inconsistent on your names, you're going to be inconsistent on your understanding. Data types bug me to no end. If you've got a data type that you've picked, use it. Stay with it. Let's go back to the medical software that I was talking about earlier. For whatever reason, they had 5 or 6 different addresses, places where addresses were being stored. And those addresses had zip code, which in the US is the equivalent of a postal code in Europe. There's 2 forms of a zip code. The classic is just 5 digits, or there's something called zip plus 4, which has additional information. Now, we were capturing zip code and storing it in a 5-character field, a 9-character field, a 10-character field, 256, 64K, and infinity. Why? Can't explain it. But what happens when you try and copy a 10-character zip-4, zip plus 4, into a 5-digit, 5-character string zip code? One of 2 things can happen. The first is you get an error, because you can't slam 10 characters into 5. And we got that error. And then we fixed it. But what's the second problem? The second problem is we've lost the specificity. It was 10, now it's 5, and if I copy it back out to another place where it can accept 10, I don't have it anymore. I've lost it because of the inconsistent data typing. And there's plenty of other examples where date timestamps are the big one as well, where you use different, it's an epoch, it's a date time, it's whatever else, with time zone, without time zone. How about structure? Let's go back to the addresses, the postal codes that I talked about. When you have structures that change, you're going to have more errors. It's going to be harder to know what's intended. I've seen in this solution addresses that were addressed line 1, line 2, city, state, zip. Line 1, suite or apartment, city, state, zip code. Line 1, line 2, city, county, country, postal code. Now, anybody who's looking at this from a coding perspective has to have a mental map of what maps into what. That's going to slow you down, and it's going to introduce errors. And we had mapping errors where the data didn't map. Why we didn't have just a single one, I don't know. That's a different argument. And then validation. If you're going to validate something, always validate it. You might validate it from database constraints, the data types, and if it's a Boolean, it's only going to be T and F, or you might have code libraries, shared libraries that validate. But whatever it is, I recommend always validating. Why? Well, today's upfront consumer of your API, for example, you may assume they're doing the validation for me. I don't need to do it. But tomorrow somebody new is going to call you, doesn't know about those validations, doesn't do it, and you're not doing the validations, and you might get errors, you might get bad data because you haven't been doing it. So I say validate and always validate. What is really funny is that this cartoon was shared within my team at my previous, most recent position the day I put it into the slide. There are 14 competing standards. Let's make one universal one for everything. And now you've got 15. How many people have seen that? Andrew Tannenbaum, famous computer scientist, this is one of my favorite quotes of all time, has been since university. The good thing about standards is that there are so many to choose from. If there are so many to choose from, why are you creating new ones? There is no need in many cases. How about international? ISO. 3166 is country, 639 is language, 8601 date time formats. Why would you create a new country code specific to your application? You've got a list of countries. I can think of 2 reasons why you wouldn't. You're working for FIFA or the Olympics, who recognize countries that diplomatically aren't countries. FIFA recognizes England, Scotland, Northern Ireland, and Wales as individual countries. But most of us don't work for FIFA. Most of us don't work for the Olympics. I've got a pre-built complete list of all the countries. Why don't I use it? There's usually industry standards that you need to follow. ICD-10 is the International Collection of Diseases, IBAN, International Bank Account Numbers. If you want to participate in the worldwide financial network, you better support IBAN. Unless you're a boutique bank dealing in billions of dollars for very, very rich people and you don't care about it. Seems unlikely. Corporate standards. How your company does business, the terminology, the vernacular, how they measure success, how they manage their finances. Those things are probably long-term baked in. Unless you are doing something completely new, very unlikely you're going to change it. And there might be business standards. Now, your company may only have one line of business, or you might be a larger corporation that has multiple lines of business, but the business has ways of doing things. Changing it can be very, very hard. A retail company in the US has something called DCPID for their items that they sell in the store. Department Class Product IDs. The problem with it is occasionally you have items that are in multiple departments, which require multiple records, which means that if you update the price on one, you better remember to update the price elsewhere, or the description, or the vendor, or size, or whatever. On a major refactoring of the supply chain application, they were going to get rid of DCPID. Let's use sequence numbers. Every item has a sequence number. We will assign a department and a class to it, but there's no need to have this DCPID that's causing us problems. Guess what? Didn't work. Too many places in the organization, DCPID was ingrained into their knowledge, into their vernacular, into how they did the processing of items, getting them from back room into the store, planograms. There was just no way that you could extract yourself without hundreds of millions of dollars. It was ridiculous, the numbers that came up. As far as I know, DCP-ID exists as essentially the primary key to this day. Now, these things are basically de jure. De jure means legally binding. A business rule is not necessarily legally binding, but it's just about as hard to change, right? This is how we do business. This is how the company does business, things like that. There's also de facto standards. ISBN book numbers. If you are a book publisher, you almost always do ISBN book numbers so you can sell it on Amazon and Abe's Books. If you're a university press or a boutique press, you might decide I don't need to do it. Great, until you want to sell on Abe's Books. There's something called the Subsonic API, which has become the de facto standard for managing streaming applications. Subsonic is a way to self-stream your own music, but its API has become the de facto standard. And it's something even like the Microsoft Word document format. It's not the official standard, but guess what? Every word processing application reverse engineers it. Now, if you need some inspiration, there are plenty of places you can go. This is the common data model from Microsoft, where you can look at your business domain, and I wouldn't say you copy exactly what's there. I would say that you could use it for ideas. You might look at it and say, that might be a better data type to use, or I didn't even think of these fields. It's not that you would copy it wholeheartedly. I don't know anybody who has, but it's definitely good for ideas. Similarly, Salesforce will sell you a domain-specific model that you might use. I have a friend in education. He currently has 6, 7, 10 CRM systems they're going to consolidate into one, and they've purchased the Salesforce educational model. Now he is mapping what they have into Salesforce, seeing what's there and what's missing. And then I do have a bunch of don'ts. Don't overuse optionality. I have, whether it's a table or a NoSQL document, something with almost every property or almost every column as optional. And what is required and what is not is dependent on some state of that object or maybe even an external state. Very difficult for the database to apply any rules. Very difficult to maintain the correct business logic because every time you access this data or modify this data, you've got to make sure that the validations are correct. And they're usually piss poor list of if then else's, if on Wednesday do this, on Thursday do this, if Fishfly do that. And that tells you what should and should not be there. Overkill. I believe that, I think it was PeopleSoft back in the day, don't know if this is true today, but their relational model had one rule in it. Every column in their table was required, bar none. If you had a new column that was applicable in only a certain series of situations, you actually copied the table and made a new table because everything would be required. A bit overkill on the other way. There's a balancing act, but too little required fields is going to cause you problems. This is more from my relational days where you would, parent table A has primary key A. Child table B of A has primary key A and B. Primary table C has primary keys A, B, and C. And I've seen it 6 deep. The problem with that is, first off, by the time you get down to table 6, you've got a very large composite key. 6, even if it's just numbers, it's going to be a lot of bits. It's going to be a large index. Every time you manage it, it's going to be difficult to deal with. That child table often doesn't care about all of the parent tables up in front of it, but in fact carries some knowledge that it doesn't need. Again, wasting time and space. And then what happens if you need to change it? B, suddenly that primary key changes and it cascades all the way down. So I'm in favor of system-generated primary keys or unique identifiers. Some NoSQL databases don't give you the choice. Mongo _ID, you basically take what it gives you. Codifying all or none, and I'll use an example of marketing preferences. I have 3 marketing preferences, and you can have any combination of the 3. I've seen places where all 3 become a single all, and none of them become none. Well, can't we just say if all of them are present, all of them are present, I've got 3, great, it's a full set, it's set arithmetic. If none of them are there, I've got no preferences. Do I need a separate all or none? And what happens when I add my 4th marketing preference. Does that fourth marketing preference automatically get added to everybody who had all? Which means if you had none, you've got to add it to everybody to be consistent. Or do I update everybody that has all to have just the 3 because the fourth one isn't there? Much better to do proper set arithmetic. In my opinion, don't separately codify your enum caller, all or none. Don't inject compliance problems. I'm not saying that you are the compliance experts in your organization, that you're the legal experts in your organizations. But over time, you will be in enough conversations that you will hear things that ring bells. You will learn enough to say, that might be a problem. If you just blindly do something and inject a compliance problem, we're in Europe here, and I don't think Norway's in the EU technically, but I bet GDPR is on everybody's tip of tongue because that is a very important compliance requirements that you need to follow. You inject a compliance problem, GDPR might wake up and follow you. Not good. Don't store localized data. Don't store a translated string because my translation is not your translation. Store a key. Don't store numbers formatted as a string. And I don't know why you would do it, but I've seen it. I'm from the US. We differentiate our thousands with a comma, and our decimal points are full stops. In much of Europe, we separate the thousands by a full stop, and our decimal point is a comma. If you store it, now you're going to have to either display it incorrectly for some people in a different locale, or you're going to have to take it, parse it, recreate it. Too much work. Finally, timestamps, especially event timestamps. Don't store with the local time zone. Store it as UTC, GMT, whatever your term of phrase is. The exception might be travel time. If I'm flying and the flight says it arrives at the Oslo airport at 4 p.m., it is 4 p.m. You can store the time zone. There is no other time that it's going to be stored. And then I would say don't repeat yourself. This is a little bit fuzzy. Now, I talked about the addresses in my medical software where there were 5, 6, 7, however many there were. There should have been one. There are times from a database perspective, you might optimize your performance by duplicating data in certain situations. If in a microservice-based environment, instead of calling out to get something that you know every time is going to be the same, you might store some of the details locally. But in general, my first choice is don't repeat yourself. Now, when in doubt, talk it out. Somebody else in your organization, on your team, peers in the industry, they might have gone through the same thing. You might be able to get some ideas and not make a bad decision. Mad Magazine was a famous comedy magazine in the United States. It had a feature called Spy versus Spy. And the spies are, of course, trying to blow each other up, and they're trying to do it based on what they think internally the other spy has behind them, what the other spy is going to do. Inevitably, they're wrong. They blow themselves up. Ha, 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 ha. That was the gist of it. So that's why I like to keep my data implementation behind closed doors. Because when your consumers know or think they know what you're doing, it may be difficult for you to evolve your data later. Think about the fact that bugs that are around too long become features in your code. Same thing can happen with data. If somebody knows too much about your data, they're going to be able to act upon it in ways that you probably don't intend. And I'm just stating the obvious, what I said before. The more somebody knows about your data implementation, it's inversely proportional to how you're going to be able to make state changes. So, can we keep our secret secret? And I think you can. Do your external consumers need to know what your primary key is, how you uniquely identify an object, a document, a column, whatever, a row in database? And I would say no. And I would say it can backfire on you when they do know that. We had a customer once who was in AWS East, sequence number generated by MariaDB 12345. The customer says, we're having some latency issues. Our first step is to get moved to AWS West. All of our users are on the West Coast. At first, we'll get rid of that, and then we can dig into our infrastructure. And it just makes sense. All of our users on the West Coast. Put us in AWS West. Okay, but the sequence numbers 1, 2, 3, 4, 5 are already taken on the West Coast. Your sequence numbers now become 21, 22, 23, 24, 25. Who's going to do the translation? Do I tell the customer, hey, we're remapping everything, here are the new numbers, and hope that they do it right? They're not. Do we write a new abstraction layer in our own software specifically for that customer to map older numbers in, but not the newer numbers? Or do we not let them know at all? And there's two ways to do it. One is the calling app, the consumer of your API or the consumer of your application. They tell you what they want to call it by. They want to call it ABCDE. Today it's sequence number 1, tomorrow it's sequence number 21. They don't care, they call it ABCDE, and anytime they pass in a request that references ABCDE, we translate. It also is possible that your structures of your data will change over time, that either you've broken things out or condensed things in, and that 1, 2, 3, 4, 5 that they know no longer really applies. And again, you're going to have to write a translation layer that says, when they say 1, I'm going to have to rip apart this JSON document to pull out a subdocument, blah, 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 blah. Better yet, keep them away from the primary key, let that be known internally, and externally, the other way you can do it is you can generate a logical key for them that you give them on their create that they keep, and again, you translate. So there's two ways, and I stumbled over that. Do they need to know your structures? Again, I would say no. Let's think about APIs for a minute. API standards usually define what the document or the response that you get from them will look like. Now, when I go from V1 to V2, there can be changes such that they are completely different. And I have to map whatever my current data structure, the persisted data is. If it's persisted, I could generate it into whatever they need. Same thing here with the data itself. Why do they need to know how we assemble that data that we give them, even if it's a straight CRUD call? I could have data in multiple sources. I could have my own local relational database. I could have a microservice call that returns something that's important on this call. I could be storing it in Elasticache, or who knows what. It's not important where it's stored or how it's structured to the caller. All the caller wants, or all the consumer wants, is the data is right. When I ask for something, I get it in a format that's known to me. How you do it in your software that you've written is beyond them. They don't care. So again, can we keep the structure specifics away from them? How about the flow of data? How we handle data, how we assemble it, or how we process it is our business, not theirs. Let's say we're storing a new student in educational software, and let's say there's 3, 4, 5 different steps that are required. We might initially do them all sequentially, synchronously. And over time, we might decide that certain things can happen asynchronously. It will return, it will create less time spent that the caller is waiting for us to complete just a random store. But do they need to know that? They need to know that we said create a student, and I've created the student enough that when they come back and say I want student Scott Sosna, I'm able to pull it up. But in the meantime, there's other processing in the background that's happened. It's not their issue. There could be some race conditions, that's a different thing. But in general, they should not necessarily need to know what the order of events is that gets them to the point where their operation is complete. Validation is coming up once again. The business rules that define perhaps structure of data, structure of a name, structure of an address field, or what are the valid values or ranges of numbers, those tend to change a little bit over time. You know, I initially accepted a percentage from 0 to 100, but now we can actually accept 0 to 200 for business reasons. Yes, we need to return errors correctly to the caller that says, I'm missing this field's out of range, this is an invalid value, lookup table value. But do they need to know the absolute specifics of, on a Wednesday, these are the 5 valid fields. On Thursday, it changes slightly. On Saturday, everything is required. No, they don't. As long as we can give them adequate feedback through whatever means, whatever technologies you're using, it should be good. This is something called, the software is Smile, and it implements a protocol called Fast Health Interoperability Resources. Now this example here, we are creating a patient. It's an HTTP post. The patient's name is Peter James Chalmers, male, born on Christmas Day, 1974. We've given an identifier 1, 2, 3, 4, 5. That's kind of the abstracting out the primary key. They've told us what they want to refer to Peter James as. They want to know it as 1, 2, 3, 4, 5. Smile implements this all in a back-end relational database. I looked at the relational database. The relational model does not match anything to the FHIR protocol, to the FHIR resources. And there's a number of different reasons that that's the case. Number one, FHIR has lots of different resources, different versions of the resources. They were gradually implementing them all. So V1 of a patient might require something else, then V2 might add on to it, and they needed to support everything. The second reason is customers needed to customize their resources. There might be a business reason that for Peter James Chalmers, I need to know his cat's name. And that's just part of their business rules, so they put cat name in there. And Smile didn't want to have to go through and change all of the tables to add cat just for him, for that consumer. And the third reason was for business purposes. Because you couldn't go to the relational database and make sense of it, because it was metadata on top of metadata, they could handle things really, really fast, but you looked at it and it made no sense at all. There's no way that you can write your own SQL statements to do reporting, to do anything bulk, any aggregations. So they'll sell you a reporting solution. That was how they were making money. So there's plenty of reasons to separate what the external consumer, the external user of your system sees, and what you do internally. Most of us won't go to the extremes that Smile does. Most of us will have data structures that kind of map what we show to the external users. But most importantly, it doesn't have to be. Now, there's a balancing act. Your internal users, your peers in your organization, other microservices that are built internally, you're going to give them a lot more leeway on what they're allowed to do. They might see your primary keys. They might make some calls with undocumented values. But at the end of the day, you can go to them and say, stop doing that. This is bad. You're hurting us. But if it's an external consumer, you really don't have that luxury, especially with APIs, right? When you release an API, it could be released forever. Depending on how many consumers you have, how much they pay you, you might say, I deprecate something every 6 months, and some customer might come back and say, yeah, we're paying you $1 million a year. You're going to support this API for the next 3 years. The ability to control our external users is much less evident. And as a result, what you expose to them or what you don't expose to them becomes kind of important. So let's kind of wrap this up. We saw this benefits of data modeling before. How about this one? Another source. And a lot of what's in here, I think, pertains to software engineering as well. Business understanding through discovery, standardization, and documentation of data sources. Do I have a data dictionary? Do I have something that, a query tool that everybody can use and query the data on their own? Stricter, more effective regulatory compliance for now and later. We talked about compliance already and its importance. Better business intelligence through data capability, literacy, and accountability. How do we use the data? How do we use it correctly? Advanced data design to support better application development, cohesive integrations, existing system. You can read, obviously. But the point here is there are a lot of benefits to knowing what you're doing with the data. The more you know what you're doing with the data, the better your solutions are going to be. So some final thoughts. I would recommend you understand your organization. Understand the business domain, the title, the target audience. What are your core competencies? What are your processes? How do you measure success? The more you know about how your organization operates, the better you are as a software engineer. And this is going to apply to data as well. Know your platform. Leverage the capabilities of your platform. We talked about most of us are dealing with a relational database, a NoSQL database, things like that. There are capabilities within that can help you, right? I can put constraints on a column or a property. I can make things unique. I can add indexes. This is all going to improve the quality of your data, the access of your data. Uniqueness is often something that we have to support. And if you do it right, it's going to improve your maintainability. We talked about where is validation being done. The closer you can to the source of the data, database server, the better your results are going to be. Now, the last one is something I experienced at a company where we were using AWS, either MySQL or MariaDB, I don't remember which, on a resource, AWS, and we are paying for ingress. So every time we store data, that is a cost. Now, we had devices that are reporting to us every 15 minutes or so about the state of the device, what applications are installed on it, some configuration information, sometimes some statistics. Now, the bare bones simple way to write that software is I receive the update from the device and I just write it to the database. Well, guess what? Most of the time, there were no changes in the data coming in. Most of the time, the apps loaded, the configuration, and even some of the metrics had not changed in 15 minutes, sometimes not in days. But every time we get the update, we're writing it. And the back of napkin calculations were, this might be costing us $75,000 to $100,000 per month. For a quick $20,000 that they'd written it, where I retrieve the existing data, I look at what's changed, nope, throw it away. Oh, this one field changed, only update that. Yes, it's harder to code, but it would have saved them a lot of money. A lot of money. This is my personal pet peeve. I hate when people come to me and say, this is your solution, and they have no idea what they're talking about. You own the tech domain. When somebody comes and gives you a solution, when you implement that solution without thinking it through, it becomes your problem. You're the one on call at 2 in the morning when the business rule that somebody insisted was not going to change actually changed with somebody else calling it. I really want to push you to look for a problem statement, not the solution, because again, their solution becomes your problem. Anticipate the future, but implement selectively. Now, point number 1 was understand your business, understand your business domain, how they do business. What that gives you is the ability to listen when new functionality is being discussed. Listen to the product people or the business people talk about what they want to do, and know that they're not always right, or they're not always thinking it all the way through. Remember the never means maybe? You might listen to them and they might say, oh, people only have one email address. Yeah, right. I know I'm managing like 7 or 8 currently. And you might look at that and say, okay, we're not going to have one email address. I'm going to implement an array. I'll only take one for today, but I've got the array and a type of email address, personal, work, whatever. And set yourself up for future success. Set yourself up for less work. If I've already got it as an array, I don't need to change the data down the road. I've already accounted for it. You might pretend your external vision might be, or your external view to the outside world is, I've only got one phone number, only one email address, but internally you've already kind of set yourself up. That's a very simple example, but again, the more you listen to your users and the more you understand the business, you're going to be able to see some of these things. Because I don't want to get in trouble, these are the credits for all the images throughout. And way faster than I expected because I'm talking fast. We're done. That QR code will get you to a PDF that you can download. I will also put it in the Slack thread for the room. That's it. I can try and take questions. I can't see anybody without my glasses, but that's all I've got. Thank you very much for your time. I really appreciate it. I will be out in the common area most of the afternoon. Come and find me if you've got questions. Also, my email address was in the download. My LinkedIn, contact me, DM me, whatever the case is. Love to talk about it. So thank you very much for your time.